This week on Quality Digest Live, we chat with Milan Kosic of Hexagon Manufacturing Intelligence about predictive measurement.
Plus, what to do when leaders overreact. That and more when we come back.
And welcome back to Quality Digest Live for October 7th, 2016. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. And if you are joining us live, you'll notice that you're joining a little bit late. A couple of technical difficulties today. Today is Manufacturing Day, a celebration of modern manufacturing meant to inspire the next generation of manufacturers. And we've talked about manufacturing today many times on this show, but I do want to reiterate what it is because I feel it's important, especially in this particular election year where manufacturing seems to be a topic. Manufacturing Day is simply a growing grassroots movement of manufacturers who are dedicated to overcoming the shared challenges facing manufacturers today. The most pressing issue, as we've said many times, is the gap in skilled labor. 80% of manufacturers cannot find the skilled workers that they need, and this gap only continues to widen. And another issue is the public perception that careers in manufacturing are somehow undesirable. And also, as I mentioned, the lack of sufficient preparatory education. So Manufacturing Day gives manufacturers an opportunity to raise and address these issues by simply exhibiting what it is they do to visitors who are curious about manufacturing. So today, all across the country, more than 3,000 manufacturers have volunteered to open up their facilities to the public so that anyone can come in and see firsthand what the heck manufacturing is all about in today's manufacturing environment. Now, I want to go back a little bit and briefly touch on the skills gap thing that I mentioned. On October 4th, an expert panel hosted by Fabricators and Manufacturers Association International, the FMA, highlighted the role that manufacturing plays in bolstering America's economy and the critical need to ensure that the sector remains a positive force. One of the panelists, Kenneth Wojtek, chief economist for the Hollings Manufacturing Extension Partnership Program, said that one obstacle to doing this is reflected in a compelling statistic, which is that today, or 2015, 45% of manufacturers cited employee recruitment concerns. That was in 2015, compared to only 19% citing that as an issue in 2009. Job openings are outpacing hiring in manufacturing, and a lot of that is due to an unprepared workforce for today's manufacturers. Scott Mayer, chairman and CEO of QPS Employment Group, said this: "Every day, the baby boomers are retiring at a high rate, and a new generation of workers in this sector is needed. But, according to Mayer, high school teachers and counselors continue to direct too many students to attend college for traditional four-year degrees when a large number of young people may be better suited or interested in focusing on the trades, on the skilled trades." So at least two things are needed, according to this article. More grassroots efforts that involve parents and educators. Kids need to see and be told that manufacturing can be interesting and pay well. And schools, whether vocational or traditional four-year institutions, need to be teaching the skill sets that manufacturers need today. By the way, even though today is Manufacturing Today and a bunch of plants are open, you don't have to wait until Manufacturing Today to tour a plant. I'll bet you that any time of the year, if you called a couple of local manufacturers and said that you would like to show your son or daughter what manufacturing looks like, I'll bet at least one of them would be able to give you a tour.
Oh, all of them. I mean, I'm sure.
If you just said you're interested, they'd make time for you.
Or if you're a school teacher, you know, seventh grade, eighth grade or something, you want to bring your kids by. I mean, absolutely. Yeah. I mean, it's a big deal. And I mean, you know, as one of those kids who was pushed into English, let's say, really useful. No, yeah, I mean, I know that there definitely was the guidance counselors in my high school definitely tried to push kids towards four-year universities as much as they could, and vocational was kind of like a backup. But I mean, you think about it, I mean, I can speak to this. I graduated with an English degree. You don't make a lot of money. I mean, you don't make a lot of money for years and years and years.
And a lot of kids just aren't interested in going
doing
to college.
that.
You know?
Why, studying.
They like working with their hands
or
whatever.
And it's like, why not let them have more of those opportunities? It's really important. We talk about the skills gap. We talk about manufacturing going away from the country. But just as important is the idea that these jobs are needed to be filled. The jobs that are here, you know, they're having a tough time filling that. And that's a really important issue.
Yep.
So thanks, Dirk, for that one. Okay. Well, the American Consumer Satisfaction Index, better known as the ACSI, the ACSI, is a national economic indicator of customer evaluations of the quality of products and services available to consumers in the United States. The index is updated each quarter and scores on a 0 to 100 scale, with 100 being the top possible score. Now, the ACSI's most recent report examines electronics and household appliances, and it contains some good news, especially for makers of personal computers. This is an interesting little facet of this particular report. Now, as a sector, PCs achieved a score of 78, which is up from a score of 77 the last time the sector was surveyed. The sector has been trending downward. This is the good news part of this. The sector has been trending downward for 3 straight years, so this result broke that rather ignominious losing streak. The ACSI breaks the broader category of personal computers into desktop computers, you can see right there, a score of 81, tablets with a score of 78, and laptops with a score of 77. Of the major individual brands within the space, Apple posted the top score with an 84, and they were followed by their very dogged competitor, Samsung, nipping at their heels with a score of 83. Now, turning to appliances, the overall sector posted a score of 82, up from 81. Leading brands are all foreign-owned, including LG at 85, very impressive score of 85, and Bosch and Samsung, again Samsung, tied at an 84. The increased adoption of so-called smart technology was cited by the ACSI as driving these improving scores across both of these sectors, both electronics as well as household appliances. So for more information, check out the story link just below this video player page, or check them out online at www.theacsi, that's acsi.org. So check them out online.
There you go. Okay, anyone who runs CMM programs unattended has probably encountered a crash that occurred when no one was looking.
Yeah.
Or maybe not a crash, but data that was wildly variable. So what happened? Nobody was around or watching when it happened, so what was the cause? Well, in the past, this would probably mean, or very likely mean, a call to the CMM manufacturer to report the crash or to ask why the darn machine is giving such inconsistent and erroneous results. And the CMM manufacturer, of course, has to immediately react, maybe send a tech out to visit the site, and he or she arrives at the site with no information on what happened either. So really, they have to try to reconstruct the scene of the crime with almost no clues. And there's got to be a better way, right? Well, that's what our next guest, Milan Kosic, thinks. He wrote the article, Thinking Differently, Predictive Measurement in Industrial Manufacturing, and is joining us today via Skype. Hi, Milan.
Hi, guys. Thank you for having me.
No problem. And I know there is a better way. We talk about it, but before we get into that, can you give us maybe a real-life example of the type of problems that might occur with an unattended CMM that might be hard to trace or find the root cause?
We have a couple of typical examples that we have running. I can bring up 2 quick ones. One is if sometimes a CMM is in a environmentally controlled room, and let's say one of the operators left the door open and their conditioning is not working or one of those things, they typically would leave the room, they come back, and they have no idea that during that time they actually gathered data that was not necessarily of the quality they wanted because the temperature might have changed, the CMMs changed performance, and all those kinds of things. Those are the kind of like the hidden things that you would see down the chain at some point and then wonder, why did something go wrong? Some more obvious ones is you have a factory next to a train track and a train changes a schedule on a 3rd shift, and then you start seeing weird variations and you have no idea why that's happening. So you have to have a way of knowing when something that you don't know what it is actually changes. And today, as you kind of said at the intro to this, it's a guessing game and a little bit of detective work, and eventually you might get there at some point. So.
Well, Milan, so specifically, why do you find that those particular types of problems that you kind of delineated there, why are those so hard to troubleshoot?
Because there's no evidence. There's no device that sits there and tells them something. There is no real methodology. And we have, done user research and gone on sites, and people tend to kind of jury-rig things, kind of to improvise. You might see a $10 Walmart thermometer sitting somewhere on the side. There might be some webcam that kind of sits in the corner, but then how do you actually correlate when something happened, what happened? So people are seeking the information, but they don't necessarily have a structure, a method to actually do it in a manner that would immediately give them a feedback of what's happening.
Now, how can technology address this problem, and that is provide more information about what surrounds an incident?
Well, I assume both of you guys, have heard 8 million articles about Industry 4.0 and Internet of Things, or as GE refers to it, industrial internet. As the proliferation of software, computing power, and the sensor technology has kind of diminished in its cost, you've seen the proliferation of platforms, devices, and other things that essentially can be installed either around the machines, in the room, in the factory, on anything else that you might possess, and then record. And the intelligence is not in the sensors itself. The intelligence is what you do with the actual information. So if you record gajillions of data, gigabytes of data of this information, the idea is that you will start seeing trends. You can draw certain conclusions so that at some point downstream, when the problem actually occurs, you can actually zero in on the cause of the actual problem right at the beginning. And you can assign that cause to the particular event. So at some point down the line, 6 months when you're reviewing production, you can say, oh, look, we seem to have a problem in this zone every single time, and it seems to be related to vibration, temperature, humidity, take a pick of those things.
Okay, now, so obviously you're with Hexagon Manufacturing Intelligence, so we can assume that Hexagon has a solution that kind of touches on what you just talked about, right? Can you just kind of describe maybe what some of the highlights of those are, and what it kind of allows you to do in terms of being able to troubleshoot or address issues when they come up?
Sure. Around earlier this year, we launched the MMS Pulse version 1.0, which is our initial, let's call it, Internet of Things device. And all it is essentially a small PC with a bunch of sensors. The sensors that are on it are temperature, humidity, vibration, and something called the crash sensor, which gets mounted under the Z column of a CMM. What those 4 sensors basically do is do the simplest possible thing for anybody who measures things in their production. Idea being that CMMs themselves are very susceptible to temperature, humidity, vibration, and if you have a crash, you would like to record the severity of the crash, so when the service shows up, they know, was it like a little tap or somebody smashed this machine into with significant force. Pulse as a device records into a database, so you can look at a history of something happening, and then when an actual event occurs, we send an email or an SMS message to the person who wants to, so that they be aware of the actual problem that occurred on the machine.
And I'm assuming this information is time stamped, right? So they know when these things occurred, right?
Correct. Time stamped. They're also tied to if they're running PCDMAS on the host software, they will also be tied to, so they know what was occurring in PCDMAS itself, so they can start tying certain events together over time. And then in the version of software that's being released now, we also, as you guys know, have purchased QDAS a few months back, which is a statistical software. We're able to also export all this data into QDAS and then tie statistical trends together with environmental trends. So you can start seeing if diameter of a circle keeps getting wrong over time, you can start tying that statistical anomaly to potentially some environmental anomaly that might be occurring.
Okay. Now, I mean, so Obviously, Hexagon has developed this. Hexagon also makes CMMs, but this really is just sensors and software. So is there any reason why this couldn't be used for other manufacturers' CMMs, or get away from CMMs? What about CNCs or other shop floor equipment that might also benefit from monitoring in real time and analysis?
Correct. The device in itself is an independent device. So whether we put it on our CMM, a competitive CMM, or a CNC machine, or something else, is really not a limit. We just have to be a little bit more knowledgeable about the process and about what does the actual piece of equipment do and what they would like to monitor. But as far as the limitations of where it can go, it's essentially limitless. It's kind of our imagination and the interest of the industry.
Okay, well, Milan and I will be going into, actually Milan, I'll just be there. We'll be going into a lot more detail on this technology in next week's webinar, Who Left the Door Open? A story of connectivity in the future of metrology. That's going to be this coming Thursday, October 13th at 2 p.m. Eastern, 11 a.m. Pacific, and you'll hear a lot more of what this technology can do for you. Thanks, Milan, for joining us this morning.
Thank you very much. And by the way, light just went off like on cue. So
perfect. And you know what? If you had a light sensor, you'd get an email on that.
Exactly.
That's right.
So thank you, guys. Thank you very much.
Okay.
Thanks, Milan. We'll see you next week.
Bye.
All right. And all of you out there, make sure you keep an eye on your email because we'll be sending a reminder about that webinar. You can register for it there. There's also a link right below the player page, yes, right here on this landing page where you can click over, and it's in Milan's article too. So a lot of ways you can find that good webinar and register for it. It's next Thursday, so check that one out. Okay. Thank you, Milan. Thank you, Dirk. Okay. Well, when leaders react rather than manage. Well, we were just talking about reaction, and now
there we go.
Another piece about reaction. So, when leaders react rather than manage by Robbie Hardy appeared in Tuesday's issue of Quality Digest Daily. Now, this is a great article, Dirk, because this one really it's kind of it's really a parable, I think, in many ways. It starts with Hardy relating a tale of a mentoree. She's very big in mentoring. It's a big part of what she does, and she had a mentoree that she worked with that she's talking about here in this little story. And that mentoree was having a bit of trouble with her current employer. The woman was a software developer, and her company had moved to an agile methodology for development. And in case you don't know what that is, agile software development really it's a lean, very flat approach to development within the software space. And it's where pieces of the project really are broken down into what they call sprints. And the team itself is empowered to make decisions based on the data acquired as part of the sprints to inform the next part of the sprint. And they kind of develop the software on their own as teams, their own little part of it. So again, it's very flat, it's very lean approach to doing this. And it's interesting because it's very different from the way software has been developed for many, many years before that. Well, in this case, Agile was working really well for this particular organization, but they had a chairman of the board who was also, I think, on the board of other companies, as many chairmen are, and I guess he had encountered through his board membership a different organization that did it in a different way and was more of a stricter kind of pre-planned development program, which is essentially what you call the waterfall development system, which really was the typical way that software was developed for a long period of time in the industry. And waterfall is really a very sequential, very highly structured, very top-down system of development within this particular industry. So those really are the two ways that people develop software really is agile versus waterfall. Well, the article, however, really is not about the pros and the cons of agile versus waterfall, although I think it's pretty clear when you read it where the author's sympathies lie in terms of which is the preferable system. It's really more about how managers manage, and in this case, the chairman of this company wanted something done, and the CEO, who was really responsible operationally for what the company was going to do or not do, kind of, I don't want to use the term rolled over, but it went along with it. Really said, well, the chairman is the boss, and the chairman is the person who is in touch with the investors, and that's what he wants done. So we're going to do it that way. And the CEO even went to the extent of saying, well, we've got to convert now from agile to waterfall, and to do that, we're going to all have to work weekends. It's not optional. You're coming in on Saturdays and you're doing this to make this work because that's what the chairman and the board want. And that's not really management. I mean, I think that you have to understand here, now again, Agile was working much better. for this particular organization. And they had done the waterfall way in the past, but Agile was working better. Neither the chairman nor the CEO, certainly not the chairman, maybe the CEO to a certain extent, was really going to the Gemba and understanding what the processes really were and how they were being affected by this change and what this change would really mean. The CEO, I think I can infer from this, really did understand how big of a deal this was going to be and that it wasn't really an effective change, step backwards really, that they were undertaking here, but he just rolled over and let the chairman say what they were going to do. The moral of the story really is that this was really about being reactive manager, not an active manager. And the fault really lies with the CEO, not the chairman. The chairman is just doing what chairmen do. They swoop down from on high and they say, well, do this or do that. But it's up to the CEO, who really is the operations person in this case, to say, no, we're not going to do that. This is working. Or possibly say, okay, we can examine it. We can gather some data and we can make a decision based on what the data is telling us, but that's not what was done here. The problem was that it was a dictate from on high that we're going to go back to this very structured way of developing our software, and it's not going to work. It's going to be an issue. This person, this mentoree, knew it was an issue, and eventually she found a different job because it wasn't the kind of company she wanted to work for. So that's really the moral of the story: is what kind of a company do you want? And how is that going to be managed? Is really
the CEO, like you said, the CEO should have simply, and he, obviously it's the chairman, but the CEO should have gone back and say, look, this is what we're doing right now. This is why it works.
Right.
I hear what you're saying, but before we move forward with that, let me lay out for you why what we're doing works and why this. In other words, I think sometimes just education is just, and maybe the chairman would have gone, oh, really? Oh, okay, well, all right.
You never know, but
you got to try it.
Yeah, you got to try it. I mean, the point of the matter is that if you're a person within an organization that has knowledge, and you know how a process is being done, and you know that what's being done now is working, and that a change would potentially be a step backwards, you've got to be very active in speaking up about that, even if you're not a CEO, even if you're just an operations person, or you're just a worker bee. I mean, if you have that knowledge, that's the basis of lean, is that everybody has voice within the culture of the organization, and certainly a CEO, you think, should be able to stand up and make that decision.
By the way, real quick, there is a flip side to this. Mm-hmm. I mean, because the other story could have been that company was doing the waterfall, and it was working for them. The chairman comes in and says, I've been seeing this thing called Agile software development. I think it works really well. Yeah. Well, they're going to dig in. I mean, the same thing could happen on the flip side too, where people just go, it's pushed down without any discussion. Even if the chairman was right, instead of, in this case, perhaps being wrong, it works both ways.
It does, and you're right. And it's almost inconsequential whether it's Agile or waterfall. That's the one that's being switched or maintained.
It's how do you handle it?
It's the process of how the manager disseminates the information and stands up for what you may know. And again, by looking at the Gemba, the CEO obviously was much closer to the Gemba than the chairman in this case, and didn't stand up for what he knew was right. So that's the moral of the story.
All right. Well, it's always fun, I think, to hear about the beginnings, the history of some new technology or idea, kind of the history of X, the history of laser tractors or the history of CMMs or whatever. So in the article this week, The Birth of In-Process Testing, the author describes how an automaker's search for something better than the hot test redefined quality on the automotive assembly line. In essence, this is an article about one of the early technical forays into in-process testing. Now, the author is Nathan Scharf, founder and CEO of Symetric Instruments, and he developed Symetric's process signature verification, or PSV, which is used to detect and analyze defects on manufacturing lines. So, let's back up a little. Let's go way back, 25 years, way back, at least in manufacturing times. Auto manufacturers did something called a hot test at the end of the line. And really all this was taking, firing up a fully functional automobile engine. They went on a test stand to make sure that it worked as it should. Well, it was expensive. It took up lots of floor space in the plant. It was bad for the environment because it's, of emissions and all that. And also, says Scharf, it was very subjective and often an ineffective test. And as with virtually all end-of-line tests, it added no value to the product. Now, around the same time, relatively early in the U.S. quality movement, it was understood that in-process testing or verification was really much better than end-of-line testing, where, by that point the damage is already done, right? You want to catch stuff early. So an auto manufacturer had approached Symetric with the challenge of eliminating the hot test, to somehow do enough in-process testing that there was no need for a hot test. Now, here's where you have to kind of put on your geek hat, and sorry, but we'll give this a try here. Symetric had already developed something called process signature verification, which basically was signature analysis. Okay, if you haven't heard of signature analysis, it's been around for a really long time, and it's simply just a way of taking signals, they could be digital signals, they could be analog signals, and creating a unique number or perhaps a waveform that was unique to that properly functioning process or properly functioning circuit board. So the idea was you would have a probe or multiple probes. The input from the output of all those probes would go into a box, and that box would mathematically or electronically manipulate those signals and generate, quote, a signature or a fingerprint. And if you know what a good-looking fingerprint or signature looked like for a process or an output, then you didn't need to look at all of the inputs. You knew that, oh, it's good. Right. Without having to monitor everything, right?
It's kind of analogous to statistical process control in a sense, really.
Well, it is in that it's a well, on the digital realm, it is a statistical thing, but on the analog realm, there's some other stuff going on. But basically, it's just a single signature or fingerprint for a process.
Gotcha.
And if you take your signature and it comes up with that number, it's good.
Within a range.
Well, it depends. Well, it depends. Sometimes within a range, or sometimes just no. If it doesn't come up with that number, it's not good.
It's a go no go.
It's a go no go.
Gotcha.
Exactly. Particularly in the digital realm. So, with Symetric's PSV, it was possible to monitor sensors on a process. So think of the assembly line. You might have, on a particular process, you might have force sensors and angle sensors and distance and pressure and so forth, and create a unique signature to that properly functioning process output. One signature that encapsulated all the the sensor data.
One ring to rule them all.
One ring to rule them all, exactly. So the next step was to identify which stations on the assembly line lended themselves to signature analysis. It's not something that can be used for everything. But Symetric was able to identify 9 or 10 workstations on this particular automaker's assembly line where PSV could be used and where it was also cost effective to do so. So by installing PSV as one of the early forms of in-process testing, they were able to dramatically improve first-time yield within a few months of the launch. Defects were caught immediately at or near the point of assembly, and the root cause could be more easily diagnosed and eliminated systematically, as opposed to you get your engine at the end of the line, you do a hot test, it doesn't work. Yeah. Okay. Well, that's good.
Yeah, you can't inspect quality into a product.
You can't inspect quality into a product. Now, all this also, kind of another wrinkle to this was all in the days before Ethernet as an international communication standard. So connectivity was still largely a pipe dream. So the data captured by the PSV, while great and helpful, really still resided in islands, silos, which was the workstations, right? So Symetric also developed a means to share data between the plant floor and the front office to allow them to, dig into the data and get some more insight into what was going on in the process. So in a sense, all of this was the harbinger, I think, at least in my mind, of Industry 4.0, which we were just talking about. And all of this began about 25 years ago. Yeah. So in-process testing and really kind of the introduction into Industry 4.0 through communicating data and aggregating data. It's kind of an interesting little bit of history, I thought.
1990, 90s, somewhere.
Yeah, exactly.
Yeah. Wow. Yeah. You think about that. I mean, it's a whole different world.
Yeah.
I mean, that's before Al Gore invented the internet. I mean,
exactly.
It's really a whole, literally a different world.
Yeah.
But it is interesting. See, I love those things too. I mean, because you understand, that everything is a sequence. Everything happens kind of, the building on the work of the ones that came before you. And, when you see that and you understand, the limitations of the hot test and see where we are now, there had to be some bridge to take you from where you were to where we are now. And understanding where you came from on that, I think, is really, really interesting for all of us now. So check out that article. Really, really good article there by, I'm sorry, was Schaaf? Mr. Schaaf?
Oh,
sorry.
Yes, Schaaf. Yeah, I forgot his first name.
I'm sorry, Mr. Schaaf. But hey,
oh, there it is.
Great article.
Throw that up on the screen. I just want to make sure I give that guy the right credit.
We can.
Oh, there we go. Nathan Schaaf. There we go.
Sorry, Mr. Schaaf. That's great article. Check that one out. All right. Well, and now for our tweet of the week, we're going to close the show with the tweet of the week, and this one comes to us from the "Would you like some cheese with your wine?" department. And it reads, "I don't have time for that," is less a comment about how much time you have and more a comment about how important something is to you.
Isn't that right?
See, it's all about priorities, Dirk. Priorities. I mean, it's just like the show. I mean, Dirk and I had to decide whether we wanted to, spend the time to script this show or if we just were going to wing it. Well, folks, now that you've sat through 30 minutes, what do you think we chose?
Yeah.
Just, which one do you think we chose?
Yeah.
Well, while you're pondering that, I'll remind you that if you're looking for more great tweets on metrology, statistics, quality, and proper time management, of course, be sure to check us out on Twitter at Quality Digest.
And that is the end of our show, but thanks a lot to Milan Kosic, the user experience guy from Hexagon Manufacturing Intelligence for joining us. And be sure to tune into that webinar next week. Milan will be the presenter there. Who left the door open? A story of connectivity and the future of metrology. This coming Thursday, October 13th, 2 p.m. Eastern, 11 a.m. Pacific.
That's right.
And Milan, we just heard from Milan, so he'll be presenting, like I said there, and I'll just be there to field your questions and feed them on to Milan, and he can answer them for you. So you all have a great weekend.
That's right.
We'll see you next week.
We'll see you next week for another big week of Quality Digest. Don't forget to check out the webinar on Thursday, and we'll see you then.
So long.
Bye. We hit it. We might have been 9 after, but it was right there.